Thank you very much for joining us today to learn about the likely core habitat for the endangered southern and central greater glider across Queensland. I'm Nicky Moffat from Queensland Conservation Council. I'm the Protected Areas campaigner here. We are recording today's webinar so that we can share with you and others who couldn't make it. So please keep your camera off if you wouldn't like to be recorded. Feel free to pop any questions you may have for our speaker in the chat box, and he'll answer them at the end of the presentation. We don't want this unique tree-dwelling marsupial to go extinct, and we know that we're not alone there. What a great turnout. Thank you, everyone who is joining us. Following the presentation and Q&A, I'll share some more about how we might take action towards saving the greater glider and its home range, and invite you to join Queensland Conservation Council and our allies in fighting for the recovery of this species and protection of its habitat. We have people joining this event from all over, and I'm here in Meanjin in Brisbane on the lands of the Yagara and Turrbal people. I'd like to pay my respects to elders past and present and acknowledge that sovereignty was never ceded. For over 60,000 years, First Nations people have been caring for country and protecting nature. I'd love to extend respect to all First Nations communities, and please pop the country you're calling in from in the chat, and also your name and where you're from. That'll help with our records. Thank you. It's my pleasure to introduce Dr. Patrick Norman to share his recent research with Professor Brendan Mackey on identifying potential core habitat for conserving greater gliders in Queensland, Australia. A researcher in Griffith University's Climate Action Beacon, Patrick conducts research in forest ecology, remote sensing, and visitor monitoring in parks. His research interests centre around using remote sensing and spatial data to assess human impacts to the environment. Over to you, Pat.
Hello, everyone. Thank you all for joining. It's going to be a great turnout, so it's very exciting. So yeah, as Nicky just mentioned, my name's Dr. Patrick Norman, and I work at Griffith University on the Gold Coast in the Climate Action Beacon. I've been working here for about 4 years, and most of my research is predominantly now on forests, and we really monitor where humans are damaging it, as well as other impacts to forests such as fires, and both Australia and globally. So I'm going to run through a recent study that we've done that was published a couple of months ago, which is going to be the focus, but I'll also talk about some background and some other aspects of our research included as well. Next slide, please. Really want to kick off today's talk with emphasising the importance of mature old growth and primary forests. I think most people here who are listening in today would be well aware of this, but mature forests are just incredibly important for both us with our ecosystem services and for wildlife. They are vital for all of our water supplies, particularly in Australia, which is always a resource we have to manage. And these old trees and the big ones actually store a vast amount of the carbon that are locked up in our forest estate, with even single individual trees making up a big difference between how much carbon stored within a hectare plot. So they are also hugely critical for wildlife. Australia, with our evolution of eucalyptus and that dominance of that genus throughout, have meant that the mature forests, these landscapes within the landscape, are critical because they have these resources, these old mature resources, and mostly around tree hollows. So tree hollows are so important for our species, with over 300 vertebrate species known to use them at some point. So really, that's what I'm going to emphasise today. And next slide, please. So this paper that I'm going to be talking about is about the greater glider habitat within Queensland, and we were trying to tease out where the most mature forest of the species within the state is located. It's an open access publication, so anyone who can jump on, we're going to share up this PDF after the presentation so you can find it, or if you just Google it, it should pop up so you can jump on and have a look at it and some associated data. Next slide, please. So just to give some background to this project, we a couple of years ago, we were set a task to try and find where the most of the primary and old growth forest was located within the USA. It was quite a daunting task, and it was quite overwhelming to begin with. So what we did was we incorporated as many people and get as many people in the room to understand how we could do this. So what we did was got about 60 forest researchers through everywhere within the coterminous, that's lower 48 states in the US, to try and come up with a method, just a simple method, to see if we could tease out where those old forests are actually located. So we did this. We're utilizing some indices such as forest canopy cover, forest canopy height, and above ground living biomass. And by splitting it up by bioregions and forest types, we can actually start to tease out where some of those old forests were located. Lovely thing in the US as well, they've got about 250,000 forest plots that they actually monitor quite regularly. It's a bit tricky to get hold of it, and it's a lot of work to try and deal with it, but we found that our modelling was actually, it worked. I couldn't believe it. Quite a seamless model across the states, and it picked out the spots. It got scrutinised by all 60 of those researchers, and it ended up getting picked up by the government there, and we presented this work and this paper to people from the White House, NASA, and the Forest Service there, which was just excellent. So we thought, here we go, we've got this method. It's a simple one. We can definitely apply it here. So why don't we do it? But instead of taking it a full landscape continental approach like this one, we thought, what's a species that's really important that requires old growth forests, and knowing where those big old forests are located within the landscape. So what better species than the greater glider? Next slide, please. Our work's mostly around the southern and central greater gliders. I'll go into a little bit more detail about that because there's been some taxonomic changes, especially up in the north. But this species is currently listed as endangered in Queensland and endangered nationally. Those have just recently been uplisted from vulnerable in the last few years, particularly nationally because of the Black Summer fires devastating huge amounts of their forest habitats, particularly in New South Wales and in Victoria. So this is an amazing species. If you haven't seen them before, they're quite big. They're more closely related to ringtails rather than the other gliding possums. Big tail, but they do need because of their size, they do need quite a large tree hollow. So making sure that those big trees actually are still in landscapes where they survive is vital for their persistence. And they tend to preference trees with over about a 50 centimetre diameter, so quite large, over a handful of tree species. Next slide, please. So our work that I'm going to be presenting today is utilising those forests, seeing if we can tease out forest maturity within the landscape. But there was a lot of background work that had been done by others that we're really going to tap into, what we tapped into. So some excellent, we know where there an enormous amount of work went in by Eyre et al. And work from Des and the herbarium to tease out where this species actually occurs within Queensland, and which regional ecosystems and species that this species, that greater gliders are dominant, that are utilised. So there's a handful of eucalypts, and there's some wonderful publications set out by them if you're really interested in teasing out where those regional ecosystems are. Where we were hoping to take their excellent work and see if we can add on something useful. We wanted to tease out where those three-dimensional kind of the structural component to their habitat. And we're utilising some other information about the size of patches required for the species. We utilised a 1.6 hectare minimum threshold because they have been found in patches that small down south, but they tend to need a much larger patch, over 160 hectares to persist in landscapes in Queensland. So we were curious about understanding how their patch works in Queensland, as well as the habitat connectivity. Because this species is quite they don't like coming to ground. It's important that we actually maintain a forest canopy across the landscape in order to allow this species to move within and around patches. Next slide, please. So this comes to what we actually did. Apologies if this gets a little nitty gritty. I'll try and keep it as simple as possible, but it's the actual techniques, not too hard. So what we did, we took the forest area where we know the species is known and likely to occur within Queensland, and we're trying to tease out every single pixel at a 30-meter resolution to see if we can give it a score between 0 and 9 of species of forest maturity. So underlying assumptions to our modelling is that for any given forest ecosystem type, the most mature forest will have the highest, will be the tallest, have the most above ground living biomass, and the most canopy cover. And if you think about most forests, they tend to, at least one of those indices will actually increase as they get old. So for some, say, if you think of some of the woodlands out west, they tend to hit a certain height and won't really grow much taller, but they will tend to fatten. So that's where our method, utilising those 3 different indices, tends to pick up where those, where some of the other methods doesn't actually work so well. And the more mature forest structure will be where most of those old growth structural elements will be found. So this is really mostly important about the tree hollows. Teasing out of our forest maturity, there's an assumption that of the older things, older the forest, the more likely it's going to have tree hollows. For our methods, which you can see on the right-hand side, we've used free and open source software, so anyone can get hold of the script. I've provided it on the paper in the supplementary methods, but it was a lot of coding. So if you're within Google Earth Engine, fair bit of Bash and R. But I can, if anyone's curious or wants to rerun this or has some interest in that, please feel free to email me after. Next slide, please. So really, we were taking out a snapshot of the Abares forest types within Queensland, and then grouping them by bioregion. And then for each of those combinations, which ends up being an enormous amount, it was 1,900 units, spatial units across the country. And for each of those, we'd give a score of forest height, biomass, and cover. And then for every pixel, we'd have an addition, so that would provide us that 0 to 9 score. For our 3 indices that we've chosen, we use the globe biomass for above ground living biomass, the Potapov et al. For the forest height, and Hansen et al. The 2010 canopy cover. So apologies about all this nasty methods, but next slide, please. So once we've done our forest maturity mapping, we're wondering where those old forests are actually located in the landscape. So we used the national tenure data set, as well as the area of forest within the formally recognised Indigenous forest estate. We chose these because these are quite formal, formally recognised and quite easy. Apologies, there's a bit of tapping going on in one of the buildings nearby, which you might hear through the speaker. Next slide, please. So on top of this, we were also interested in where the species can actually move through a landscape. So we used the least cost paths approach, if anyone's worked with any connectivity mapping before. So this is really saying, here's a pointed landscape, let's say a theoretical point where a species is going to go, and we're somewhere nearby. What's the best way to get through? We incorporated our forest maturity mapping within this least cost paths analysis. And we end up having to make our own workflow because of the large area. If anyone's interested, that the map on the right-hand side is actually of northern New South Wales, but it's just a bit of an example. In total, we assessed around 4.7 million potential pathways throughout the species range. Next slide, please. So what we found was across the known and potential distribution within Queensland, there was about 14.2 million hectares of forest, so very large area. The species is probably not going to occur in all of those areas, but we wanted to really tease out where those old stuff was. So about 35% was found in these older, more mature classes that we were mapping out. These are those classes 7, 8, and 9. This is where that we assume most of those older, more primary forest kind of related metrics would be found. So this is where those tree hollows. And of this 35, about 63% was on leasehold and freehold lands, 21% on multiple use public forests. This is mainly state forest and mostly in the southern part of the range, and about 13% within nature conservation areas. Next slide, please. So by teasing out where this forest maturity and where they're actually located within the different tenure classes, we found that there's quite an interesting distribution of how old the forest was amongst the different tenures, which you can see on the right-hand side and on the table on the left. Most critically, most tenure classes tend to peak at about 4 or 5. So this is within like an intermediate age category, except for nature conservation reserves, which we would expect most of nature conservation reserves would have the oldest forest, and we did find this, which was good to see. Our metrics are also a little bit, they can be altered by some natural processes, so such as cyclones, big windstorms, and fires can actually drop down these forest age. So we wouldn't expect it all to be really old and lovely in nature reserves, even though they tend to go that way. Next slide, please. Additionally, we found that as far as the patch is concerned, most of the forest patches were quite small. They were within 1.6 to 5 hectares in size, but there were still quite a lot of big patches of more mature forests within Queensland, particularly in some of the areas around the multiple use public forests in the south and some of the nature conservation reserves. So around Carnarvon and the central tablelands was some pretty large areas, and within Barracuda and some of the more inland multiple use the state forests down the south, as well as much of the tablelands up the north, which is in that point where the species is still a little bit unsure of which ones it is up there. But I'm sure if anyone has any further knowledge on this, I'd love to hear a lot more about that, because I'm more of an expert on remote sensing in forests rather than the species taxonomy. We also found that within the formally recognised Indigenous estate, there was very, very large areas within the component of the within the Indigenous estate. So there was different classes of formally recognised Indigenous estate where there's direct management, but then there's also other management. So I think it really highlights that a comprehensive kind of a voice within the Indigenous peoples within those areas is hugely important for this conservation of this species going forward. Next slide, please. For the connectivity results, we found that there was 88 really important corridors that we found. Large percentage of these were actually within leasehold lands, particularly up in the northern part. There was quite a few massive pinch points that we identified, particularly as you can see on the left-hand side. That's the connections around Barracuda State Forests, and that one to the south is quite vital, as was that were near Carnarvon. It's where the big blocks of forest tend to pinch up to at least have a canopy cover. 52% was found on the formally recognised Indigenous forest estate. There's also a couple of odd ones showed up that were of interest, particularly around the Sunshine Coast. There's also one in the western parts of Brisbane that showed up. I'm not sure if this connection still persists. This is because of our indices being some imports from about 2010 to now. There's within areas that are really subject to damage. The connections might necessarily still be there, but they could flag some important ones. Yeah, that one I'm quite curious about. I had a bit of a zoom in, and it looks like it's still persisting. So I really hope, at least for many different species, that connection still exists. Next slide, please. So once we've done all this mapping, we were thinking, I'll be sure that this is actually representing those old forests. So in the USA, we had those extensive forest plots that I mentioned, and they actually scored the forest between young, intermediate, and old, and with additional serial stages that we grouped, and we found that it worked well, and that's where that 7, 8, and 9 really came from. Unfortunately, we didn't have that kind of data here. So tried to explore some different options and some different data sets, but we end up picking airborne LiDAR. So this is the where a plane's flown over and shot laser beams down on the ground, measure the return. You can actually figure out how tall the forest is. You can also do some other density measures. For this, we used about 360 gigabytes of airborne LiDAR data, and we teased out where forest height, the forest height index is. So making sure that we were at least double checking our method. We found that there was a significant difference amongst the forest maturity classes for height across all the different ones tested. I've shown in the top left-hand side, you can see a bit of an example of what this looks like. So this is a point cloud from just on the Gold Coast, actually, one of the suburban parks. But you can see that's what the scores came out as. Number 2 is quite young, short. 3 is starting to get a little bit better. 5, you're getting into that intermediate. It's the forest is really is coming together, and it's going to be starting to look good. And then those 7, 8, 9s, that's where you're starting to see the forest really mature, and starting to get those wonderful tree hollows. Next slide, please. As with everything, especially within modelling, there's always a few caveats of where the modelling might necessarily excel. So in the north, we found that the globe biomass, the biomass layer that we've used to do this modelling, had some scan line errors. So this is a Landsat 7 issue, that when they flew, a bit of the hardware and software stopped talking to each other, and you end up with some pretty funny banding, which you can see on the right-hand side. I've tried to get rid of most of this, but some of it persists within. So you'll see this issue if you ever look at the data. Areas of low natural productivity, those areas of either the really extreme end of where forests grow, or at sea, either in elevation, if you're looking at somewhere near Alpine, it would really shrink down, or up the higher elevation areas around Lamington, you'll see the forest actually starts to shrink because of temperature and from wind, as well as in the really dry areas, the forest will naturally get smaller. So in these areas, we'll find that it actually starts to flick to look like younger forest, but it's not always the case. So it's quite an important consideration if you were using this data set, is making sure that that's not happening, and to identify those areas. And also within ecosystem types and forests, within bioregions that have been damaged heavily, say some areas in the Brigalow Belt, where most of the forest's actually been pushed to be quite, in the northern Brigalow Belt, sorry, the forest is actually quite young, considering it's in a lot of areas, and it ends up skewing the modelling a little bit lower, but it still picks out the best of what's left. So these are those areas, even if it's not necessarily the most mature forest that once would have occurred, it's still the best forest that's there and the most productive. Next slide, please. Some potential applications of this modelling. We're thinking it could maybe inform some conservation planning for greater glider in Queensland. We've passed this data set on to Des, who are looking at it and seeing if we can tease out some areas. So mainly looking at where some of the core habitat and teasing out where those old forests are located, as well as those identifying important movement corridors. I think there's quite a bit of usefulness in the corridor space, because our modelling tends to show where there are corridors, but it does identify the absence is quite important. You'll see if there'll be places where there is no remaining corridor across, say, big areas of habitat, and some forest restoration would be excellent within these areas. Most of the northern Queensland is on leasehold land, or outside of protected areas and state forests. And in southern Queensland, they tend to be within the state forests. But ensuring that we can try and target some areas for protection and really making sure that those old forests are being locked up into nature conservation reserves in the future would be excellent. Be really good to identify some areas that are going to be under threat from industrial development settlements or extractive industries to see if we can ensure that either they don't occur within the greater glider habitat, or if they do, we can really tease out where we can make some better decisions. Input to regional planning, we've also had a fair bit of outreach from some of the councils. So I know that this data set's been used by some of the ones in South East Queensland already, which is excellent. And it'll be wonderful to keep going. So please email me if you were after the data set, and I'll send it through. Enhancing corridors through priority patches of restoration is hugely important, as well as potentially the data set could be used in some of the global biodiversity framework targets, such as the 30 by 30, or lifting Queensland's protected area estate up to 17%, which would be excellent. Next slide, please. If you're interested in this data set, in having a look at this one, so rather than having a look at the GIS, I have made an interactive map, and it's on just a Google Sites page. We'll share this PDF, so don't worry too much about the URL, and because you should be able to click on that once it comes through. So you'll be able to jump on, have a zoom into where you're interested, and see if you can have a look. So I think I've got all the different tenure classes and the forest maturity layer, as well as the connectivity mapping is located on this, as well as some information about the paper and some other details. Next slide, please. So the next steps, this is the other component that I'm getting quite interested in. Love to expand this method across the entire species range and see if we can look at where areas within New South Wales and Victoria are, as well as the ACT for the species, and see if we can really tease out where we really need to prioritise some conservation for this species. I'd like to apply to other old growth dependent species. We've had a look at, we've had some positive results from Western Australia, looking at some of the black cockatoos over there. So I'm currently writing up a paper around that. And we're curious because our metric should still apply for some of those other hollow dependent species, such as a good candidate would be, say, the large forest owls. And there's a big range that this data set might be applicable for. I'd also love to get some more on-ground data from everyone, from citizen scientists or from anything else, to see if we can tease out where those thresholds of our maturity data set really lie within the landscape. So currently we've got it set to 7, 8, 9, and this tends to be where most of the old forest occurs. But within each forest type and within each region, there'd actually be thresholds in which we know we can set a boundary and say, look, this is where those hollows are occurring. So either any information about forest maturity, where those old ones are occurring, or with the species records, because of greater gliders' dependency on old and mature forests, they are a good candidate to reveal where those mature forests are actually occurring. So we're trying to set up a little bit of an interactive citizen science app, which I'm just in the process of fixing up at the moment. So if anyone's interested in getting out there and taking some field measurements and things, please email me, and I'll try and share that around once I finally got that updated. But also we'd like to regularly update this layer and really make sure that it's up to date. Things change pretty quickly. Areas get cleared, or the forest will change. So understanding where this goes forward in, say, 10 years' time will be quite important. So I'd like to reanalyze this. We'd also like to really utilise that airborne LiDAR. Queensland doesn't have a full extensive range of it yet, but New South Wales does. So to tease out that, it's a wonderful data set. We can really, it's quite an exciting time, because instead of taking these big global models and things, we can really make them our own. We can say, here's a tree, here's the canopy, this is how tall it is, what's a likely species, and then we can start to really get out some forest metrics. So that's where we're exploring at the moment. Quite exciting times. Next slide, please. I would like to do a big shout out to Great Eastern Rangers for helping fund this project. They do some awesome work about for habitat connectivity throughout the Eastern Australia. So big shout out for thank you for funding this. And also big thank you for everyone listening here today. Thank you for joining, and I think we're up to the area for questions. Thanks.
Thank you so much, Pat. That's fantastic. What an exciting research, and the results are so wide-ranging. We have a bunch of questions, so we'll open the floor now. I would like to first ask one from Sunshine Coast Environment Council, Pat, if that's okay. And you might like to go back, if you want, to the interactive map. Narelle from Sunshine Coast Environment Council is keen to know more about that Sunshine Coast location that you mentioned.
Oh, great. Yes. Yeah. The Sunshine Coast has got some amazing, as you'd already know, Narelle, some wonderful forests in amongst a bit of a patchwork. So it's understanding where those links actually occur is quite important. So yes, please jump on and inspect that interactive map. Any feedback is welcome as well, where it's working, where it's not, because we'd love to refine this method and these data sets. But yes, that interactive map is available when maybe I'll share up that link. Oh yes, there it is, come through. Excellent. Thank you for posting that in the chat.
Great. We also have Teresa Eyre with a question. And Teresa, if you'd like to ask this yourself, please just indicate by writing in the chat channel. Otherwise, I'll put it to Pat myself. Teresa just wanted to know, so Pat, were you able to validate the mapping with site-based data with hollow-bearing tree densities? And a follow-up comment was, I guess I would be recommending to keep in mind the potential versus known habitat for greater gliders for prioritising restoration.
Yes, yeah, great questions. Yeah, thanks, Teresa. I tried my darndest to get hold of any data set that was with that contained that critical point where those hollows start occurring across the range. I could not get one. I couldn't find one. Please, if you know of one that's publicly available, I'd love to tap into that. There's a lot of applications for that for a wide range, not only this part of our work, but a lot of our other forest research. So that would be hugely valuable. And yes, yeah, thanks for pointing out the potential unknown. Your excellent work around the different regional ecosystem mapping. I probably just to reiterate, it was found that there was about 254 confirmed greater glider habitat regional ecosystems and 124 regional ecosystems that were identified as potential habitat. So what we've done for this paper is we've included them both. But yes, it's very important to understand the difference between those two, because some are obviously more important for the species. Thanks.
Teresa did want to say a word. Is our tech team able to put a spotlight on it? Oh, we're having trouble locating you in the sea of faces, I think.
I'll just turn on my, can you hear me?
Oh,
yes.
Yeah. No, sorry, you answered my questions. So thank you very much for that. And thank you for the presentation, QCC. It's fantastic. So that's all. Hi, everybody. Okay, I'm going now. Bye.
Interest. Dylan Pugh from Northeast Forest Alliance. Would you like to ask your question, Dylan? Just unmute.
Well, I had two questions. One, you had some data there from Northeast New South Wales on least cost pathway. So that would be very useful for us. And I don't know what other data you've got for Northeast New South Wales. But the second question, so, maybe I could get your email address for that. The second question, though, relates to how do you deal with scattered old growth trees in regrowth, like i.e. in log forest, and also the relationship between greater gliders and mature trees, i.e. for feeding as well. So just whether you can capture that variation in disturbed landscape.
Thanks. Great questions. For Northern New South Wales, we've actually another project looking at the connectivity through there that I'll be hoping to publish soon. So I'll release that and I'll send you an email, Dylan, when that comes through. As far as teasing out where those mature forests, those trees, because we worked on a 30-meter pixel resolution, it'll pick out most big trees, but in certain landscapes, if the canopy size isn't really broad, we might be losing some of that detail, but 30 meters. So yes, it'll pick out a single stand, say, or a few individual big trees in amongst a cleared landscape. It tends to work pretty well with that.
So how do you categorize that though? Do you have a disturbed mature category or something like that that
Yes.
picks out those areas that still do have some remnant hollow bearing trees in them?
Yes, yeah, that 0, our categorization will go from 0 to 9, with 9 being the most mature. But yeah, you'll quite often it'll see really low scores, and then you'll hit, say, a riverine, bit of riparian vegetation or something, somewhere that's been left originally, and then it'll jump up to those higher values. And you do see that in amongst a lot of the highly degraded landscapes, say in the northern rivers. Oh, I'd like to do a bit of a flag. I'm currently working on a big project in the northern rivers, and we're really teasing out some of the LiDAR component of this. So we're hoping to take this kind of data set and do it all for the northern rivers. So yeah, watch this space. We'll hopefully have that out soon. Thanks for the great questions.
Yeah, thanks. And thank you, Pat, for your informative response, and Dylan for the great question. Just continuing that theme of small remnants, Andy Grodecki, I had a question. Andy, happy for you to ask this one if you'd like.
Yeah, sure. Thank you. Yeah, how relevant or important do you think the research by Professor Brendan Wintle from University of Melbourne is? His research has looked at the importance of the very small remnants, even in the peri-urban urban areas over, and critically endangered species. So yeah, interested in your comments about that.
Yeah, that sounds good. Yeah, Brendan, do you know Brendan Wintle? I don't think he'll be watching today, but just in case. Yeah, there's an amazing array of research, particularly down south. There's a lot of work on urban remnants, and they're fascinating. Our modelling should hopefully, in most cases, work quite well within those urban landscapes, particularly if they haven't been altered and changed in recent times. Had a bit of a deep dive into that, but yeah, I think it's hugely important that a lot of this research is still conducted, and teasing out where those big old forests are located in the landscape is just so important for species conservation across all of Australia. So, yeah, thanks for the question.
Thanks, Pat. And look, there's a really great question in here from, I'm not sure what their actual name is, but Newport K, if you want to unmute yourself, just regarding fragmented habitat and the challenges of constructing corridors.
Yeah, hi guys, sorry. Yeah, I think it's kind of just stemming on from what you've been discussing, but in regards to corridors and fragmented disturbed habitat, in areas where there are where it's fragmented, but they have like the key attributes like your hollows and the large DBHs and the complexity. How is there a method that we can determine the corridors, like when mapping them or trying to explain them to our clients, that we can explain to define what a corridor would be?
Absolutely. There are quite a range of different methods to assess habitat corridors. We use the least cost paths, as I mentioned earlier. So this tends to focus on what's there, but there are some other different metrics, circuitscape and conifer. There's a few other different ones that will actually show where it's not and where would be the best spot for restoration. So we had the conservation spin, but if you're actually actively wanting to regenerate a thing, I'd have a bit of a look, and please feel free to email me and I can send you through some different ones. Particularly when you're dealing with areas aren't too big, some of these methods are quite easy to run if you've got GIS capabilities. Circuitscape's particularly good.
Okay, that's
just
great.
Unfortunately it falls over at a state level.
Okay, yes, thank you.
Thanks. Oh, and also like to, Great Eastern Ranges, they've done a huge amount of work with restoring, they've got these regional partnerships. So there's definitely some scope to look into some of the things that they're doing as well about corridor restoration and work in that space.
Okay, thank you.
Thanks very much. Look, there's a question here from Christine Carlisle. And before we throw to you, Christine, just I have noticed there's quite a few people in really active community groups across Queensland, some of whom are working on their own projects to protect greater glider. We do have probably another 10 minutes of chat time, and I just wanted to invite some of those community groups, and also if there's any professionals who have ideas or would like to discuss ways of getting this research acted on. If you have insights that you'd like to share with the group or discuss or ask questions with Pat around those themes, just to pop those ideas, flag that in the chat as well. Christine, over to you. If Christine's there.
Yes, I am there. Sorry. Yeah, so it was just in relation to we do work in Central Queensland with you know, doing submissions and things on expansion of mining or new mines and things like that. And I just wondered how useful the research is going to be with that, you know, whether that's likely to be weighty. I know we always put into our submissions just about devastation of this much koala or greater glider habitat or whatever, but we haven't really pointed to your research. So I just wondered about that. And the other thing was offsets, which I have in the question also, is that mostly they exonerate themselves and say, well, we'll cut down this area, but we won't cut down that area. And in relation to most of a lot of the country on fire at the moment, whether any of those areas you've mapped are being used as offsets. Thank you.
Thanks, Christine. I've got happy to share up the GIS data sets aren't on the website, but if you email me, I can share those direct link to a server that you can just download the data sets if you have GIS capabilities in that space, but also the interactive map identify a lot of those areas. As far as offsets are concerned, they're really and they're a tricky one, aren't they? Especially around a lot of the carbon offsets and the things that we have, the prioritizing restoration of things. And restoration's wonderful and it's targeted, but if it's removing old forests, you know, you're not replacing one for one. So it's really important that we start to look at where and what are the characteristics of the things getting removed, and understanding that this is not just something you can instantly replace, and it's going to take upwards of 100 years in many cases of to get the forest back to an age in which it's going to be sustaining these types of animals again, particularly those hollow bearing dependent species. Did I miss anything? Thanks, Christine. It's a good question.
Great. Jessica Lovegrove Walsh. Hi, Jess. If you would like to put your question, she wants to talk about citizen science.
Absolutely. Thank you for this. Thank you for the great presentation. I know greater gliders are a much loved species for a lot of the community members around there. So my question is on citizen science. What sort of information are you looking for?
I think the really big one is tree hollows would be just excellent. Knowing a point location, and yes, there is either even a tree with tree hollows, because if we can marry that up with some of our modelling and a lot of our other things, it's so important to understand where those trees occur. I think that's the big one. DBH is also nice. That one's also a good one that starts to really tease out where we'll be looking at the old things. But yes, tree hollows and understanding, because it's always maturity. We ran a bit of a project a few years ago looking at identifying what primary forest is, and even something as simple as what that would be gets messy. So understanding maturity is also a really quite a subjective thing. So at least in Australia, we've got these things that form on the tree that are quite that identify that this is starting to get pretty old. So yeah, tree hollows I think would be the best kind of information.
Yeah, just on that, have you heard of the Hollows as Home citizen science project, and was any of that data utilised?
No, I haven't heard of it.
Okay. Yeah,
What-
by
what was-
University of Sydney and Australian Museum, I believe. So that's something that I've seen, but would be happy to promote more widely as well. I think everyone would be.
Excellent. Excellent. Thank you very much. Yeah,
Thank
that's that'll be massively valuable for us. Yeah. Thank you.
Great discussion. Look, there's one last person, Liz Gould. I'd just like to invite you to ask your question, and a heads up that if those who are involved in the SEQ regional plan are listening in, and you might like to respond to this, feel free to just pop in the chat, raise your hand.
Thanks, Nikki. Yeah, just I've seen some of the draft work and worked with Pat last year or whenever it was when we were sort of trialling our work for greater and yellow belly gliders. But obviously your mapping, Pat, has so much value to so many species that are hollow dependent particularly. And yeah, love to see how this could be used. I understand from the SEQ Community Alliance meeting the other day that the review of the shaping SEQ so far is just an interim measure, but they're aiming to a full review of shaping SEQ over the next few years. And of course, there's the bioregional plan for Southeast Queensland. So having your data informing that process is critical. I know Teresa's here, but I know she can't comment on behalf of all of government, but just making sure your mapping's got to the right places. Yeah, just wondering if you've got any insights on that.
Oh, thanks, Liz. Yeah, thanks for the shout out, and thanks for having a look at the earlier stages of this and helping to definitely help validate this data set in Southeast Queensland. So thank you. Yeah, it's gotten a bit more traction than I was expecting. So we have managed to spread this data set a bit further and wider. So I do hope that it's starting to get into or it's starting to inform some decisions, especially if it looks like it's working within your landscape. So yeah, I hope it's going to be great. Thanks, Liz.
Great. Well, look, unless anyone else has a comment, I know there are a number of people who are very active at the moment in SEQ that are on the chat. So I'll just pause a minute, unmute yourself and feel free to make a comment.
Hi, Pat. It's Misty here from Burnett Catchment. We're sort of Bundaberg and west of Bundaberg. We've got some greater glider activities occurring at the moment. Would any of the data that we have in our projects in terms of sightings, I heard the comment about tree hollows, which I'm happy to provide data on. But in terms of sightings, is that of use to you at all?
Absolutely, hugely. That would be, yeah, any information is excellent. It's so quick and easy to marry up spatial data sets now that it's invaluable to have really good field observation. So do a lot of this stuff in big areas, but yeah, anything, that would be amazing. Thanks, Kristen. Okay,
I might send you an email and just work out how best to deliver that data to you on an ongoing basis. But I'd also be really keen to cross-reference the modelling data that you've got along with our spatial data of sightings and habitat, which would be really interesting for some of our projects and for community too, because a lot of the work that we do is on agricultural lands, not just in protected areas. And yeah, a lot of our grazing producers are really keen on this stuff as well.
Fascinating. That's really good. Yeah, I'll so if you send that email, I'll share out the GIS data sets. So I'm free. Yeah, anyone attending, please find me an email if you're curious of getting the input layers or the output layers, I mean, from this data.
Excellent. Thank you.
Thanks. Great question.
We'll
this is Vanda from Koala Action. We're doing a lot of advocacy in relation to retention of mature habitat for koalas, and I was hoping to ride in under the tailcoat of greater gliders too, particularly in the Moreton Bay region and in the southern part of the Sunshine Coast region. So I had two questions. First of all, on the interconnectedness of having two species under that one umbrella from a conservation advocacy perspective. And number two, the up-to-date mapping and the land clearing and how you deal with the changing landscape, particularly in the urban and peri-urban regions.
Yeah, it can be really messy, particularly on that second question, when things change really quickly. That's why it's really good to start. These indices are great, but they're not necessarily always up to date to be really clean. So it's actually good to, unfortunately, build your own, especially when you want to tailor things for really specific areas. But yes, yeah, definitely there's a lot of capabilities now that input Landsat and Sentinel imagery and then tease out where forest cover is and really to identify where those changes are. That the input height data set is actually the LiDAR is sitting on the International Space Station and firing down laser beams as we speak. And that data set's getting filled in more and more. So we're actually starting to get a really lovely forest structure, still with data rolling in, which is great. So you don't have to just rely on those the planes flying overhead to get that data anymore. Sorry, I actually missed the first question.
In relation to putting greater glider habitat and koala habitat and covering the two species under the same habitat conservation retention umbrella.
Yeah, they we had a bit of a tease around to look if we can utilize it for both, and there'd be a big chunk of overlap, but koalas can handle a little bit more disturbance, is what we found. I'm sure I'd love to hear from anyone out there that has done a lot of work on both and to understand where that threshold is. But I think as far as graders, we'd be looking at the mature end, really mature, where koalas would probably go back a little bit.
Koalas prefer mature habitat as well. They're not left with much choice. Sometimes they have to settle for something less mature because there's nothing else available.
Yes, yeah, they can still, can't they? So it's that, yeah, that cut is always still quite tricky. But yes, yeah, no, it's a very good point, and we had a bit of an explore, and but I'd still love to, if you could jump on and have a look at the that mapping and provide some feedback would be excellent. Thanks.
Thank you so much, and for all of the wonderful engagement and comments. So many great community groups out there doing work, and I'd love to connect people in an event that we can invite you to through a similar sort of format as a meeting to take forward the citizen science project that Pat is putting out there. Thanks, Pat. I just want to say very huge thank you to you both for doing this work and for communicating it. It's a rare thing to find researchers who have all of those skills, and you're remarkable, and so is Brendan, and the work that you're doing is fantastic, so thank you. I'm really thrilled at the turnout. We had more than 300 people RSVP'd for this. And in terms of your significant findings from this research, look, I find it really alarming, as I'm sure many of you do, that the majority of greater glider habitat is unprotected in Queensland. And we know that that habitat is on leasehold, and private land is threatened by deforestation for beef and housing. And we know that state forests and some leasehold land are threatened by logging. So I think we know that it's clear that the system is failing greater gliders and other arboreal marsupials, let alone birds and other plant and animal species that depend on this habitat, right? We need a better framework for threatened species recovery, and we need it fast. So more protected areas and evidence-based land management. We have a global biodiversity framework as a guide, but we need to implement it in Australia and in Queensland. In Queensland, we're the lowest proportion of our land mass secured and protected areas. So unlike other states, you can see on this slide, up to 42%, that's in Tassie. We've only got less than 9%. So 8.3% at the moment is the official figure. For Australia to meet its 30% protection target by 2030, Queensland really has to get to 17%, and that's about 15 million hectares that need to be protected in a network of reserves that need to be representative of our extraordinary ecosystems. If I could change the slide, thanks guys, thank you. So right now, the Australian government is undertaking consultations for a review of nature laws. I believe this is a really great opportunity, probably the biggest in a lifetime, to fix our broken legal system as far as nature and the environment is concerned. The EPBC Act, Environment Protection Biodiversity Conservation Act, is being reviewed right now. So I think there's a serious risk that this review will be derailed, like so many good initiatives, and we urgently need informed people like you to speak up and make sure Tanya Plibersek sticks to her vision of no new extinctions. In the chat here, you'll find a link to an action page on our website. So if you would take a minute to have a look and send a note via that page to your federal members of parliament, please do. On Saturday, if you're around, please come along. We've got a wonderful event in Maruka. If you're Brisbane based, the Nature Forum is on for a couple of hours that morning, and there's links on our website as well. So unless there are some extra discussion or comments, I'm happy to open the floor for a couple of minutes if anyone wants to make a chat note. Otherwise, we might wrap.
And I've got a second to have a quick chat.
Oh yes, is that John Winter?
No, it's Kerry Wynn here from Glenwood Wildlife Awareness.
Oh, hello, Kerry. Yes, and also John Winter, if you are there, do make your point. I think you wanted to say something.
I'll just jump in quite quickly. Where we are here, we're encountering an enormous amount of fresh land clearing in state forests. Got glossy black cockatoo, Regent honeyeater, endangered habitat here. We're working with HQ plantations. They've put out circulars and things like that to help their workers understand glossy black reed trees, etc. But what's happening? We've got so many projects with the Imbil pumped hydro, with their power line corridors. We've got the new Bruce Highway clearing Curra State Forest. That's been done. We've got the forest wind, putting 200 and something odd wind towers in glossy black cockatoo habitat. We've got clearing going on in potential clearing in Cooloola National Park. We're going to put 35 cabins around Lake Tuna. I don't know how many people are aware of the fact that the Queensland government is doing that behind our backs. And we've got a lot of tree changes moving to the region, buying 2-acre blocks and clearing them, old growth trees, and the councils haven't got any covenants on these blocks. They're just letting it happen. Where does it all stop? There's huge implications for our water cycle. The reason we're drying out is because of deforestation. Someone just commented here before about the importance of forests and vegetation for the water cycle and our afternoon storms and things like that. Is there a strategy? Can we develop a strategy to sort of slow this development and this land clearing down? It's just horrendous. We've got glossy black gliders, glossy black cockatoos and gliders here in Glenwood, and we're starting to do surveys, so we're going to be able to provide some data soon. But people just move in and in amongst glider habitat and just taking the trees out. What sort of strategies can we do to give these councils, make these councils take notice and start preserving in our rural residential areas? That's my question.
Did you have ideas?
I think you'd be better placed, Nikki. Do you think? Yeah.
I look so much to unpack there. I'm
sorry to impact all that, but
I think with the getting involved in your local community, which it sounds like you already are, and taking advantage of the SEQ regional plan update that's happening at the moment, do just get in touch with us and we can connect and take some of that forward.
Yes.
And a last shout out to John Winter. Are you around, John? I hear you want to say something, mate. Can we find him? To unmute. Oh, so many people. I think we might have to leave it. So look, just want to thank again from the bottom of our hearts. Thank you so much for the work you're doing and for all of the other amazing researchers and advocates on the call. It won't be the last of webinars like this. We'll be doing many in the coming year leading up to the election, and we'll be advocating for all, both parties to take very strong action for nature. So thank you again and have a lovely afternoon.
Thanks for attending, everyone. Thanks.
Thanks, everyone. Thanks, Pat. Thanks, Nikki.
Right, cheers. Thank you.